Welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Nwaka, and I am your instructor. Over the 4 years, we have done extensively well in training the younger engineers in the area of the building design, which we focused more on reinforced concrete structures using a practical and a real-life example, and we have done extensively well. We have cut across almost the whole Africa, and we have also cut across almost the whole South American countries, and we have also done extensively well in part of the Asian country, for example the Indians, and also we have done a lot in the Middle East. And within these 4 years we have trained more than 17,000 engineers, and in our mentorship training we have trained over 700 engineers, 742 engineers as at today that have passed through our Ekidel mentorship certificate, and we have seen the results that it has done extensively in terms of younger ones designing to standards and also producing or generating a good design drawings. And we used just two softwares to achieve this. We used Tekla Structure, which is a very good software in terms of reinforced concrete building design, and also AutoCAD, which we focused on that using the Stonebridge templates to perfect the structural detailing. Yeah, alongside other softwares like KCSoft and other ones, but the major two was Tekla Structure and AutoCAD. And we have used these two softwares for the past 4 years dedicatedly to train younger engineers. Now we are about moving into the oil and gas industry, knowing that as a structural engineer or civil engineer, you don't just depend only on one sector. Most times you can choose to move into the other sectors. So we are now introducing Ekidel Oil and Gas Academy, which we are still going to use the same platform, which is the Ekidel channel, to also train this. And if you go to our about page, you can see that we listed many softwares on our about page, and for the past 4 years we have only focused on one, which is on two, Tekla Structure and AutoCAD. And most people have been asking, when will you guys take Revit, when will you guys take Tekla, other softwares and all that. Yeah, which we have been answering that we will when the time comes, because all the softwares listed there, which we will still list more on that place in the time to come, are being used mostly for different sectors of engineering engineering. So we are now, since we're now moving into the oil and gas industry, we are now going to introduce a new software, which is Tekla Structures. Now Tekla or Tremble software has majorly three major softwares, which is the TEDS, the Tekla Structures, and Tekla Structural Designer. Now we are using the Tekla Structures extensively to do this, and not the Tekla Structural Designer. Now the reason why we are using this software is because of how advanced it is and widely accepted around the world. Anywhere in the world it is accepted because of the complex work Tekla Structure does. Now in that note, the list of softwares that we will be using for this oil and gas training, knowing that oil and gas is divided into two major parts, the onshore and the offshore. So the onshore oil and gas deals with anything about that to do with land, and the offshore is around like in the ocean, just like the offshore. So in that course now, we are to deal with, on the first phase, we will deal with the onshore structures, and we are focusing majorly, knowing that our channel Ekidel have majorly focused in building structural and civil engineer alone. Now Even at that, other people have been calling, for example, mechanical engineers, electrical engineers, and different disciplines have been calling that we should introduce, that they like the way we are teaching, and that we should introduce other disciplines. But we are still looking for credible hands to do that. But until then, we are focusing majorly on structural and civil engineering discipline. So in that course, a structural engineer or a civil engineer can also work in oil and gas. Most of the younger graduates or younger engineers thinks that oil and gas industry is majorly for mechanical engineers or engineers that studied petroleum engineering or electrical engineers. No, oil and gas in oil and gas industry, without a structural or a civil engineer, none of the structures will stand, because all those pipes, all those oil pipes that the mechanical engineers designs, the piping engineers designs, all sits on a foundation, and that foundation can only be designed by a structural or a civil engineer. All the steel structures that you are seeing, without a structural engineer designing them, they cannot stand. All the road paths, all the roads that you're seeing in the facility, without a civil engineer designing that road, there is no way, there is no access way. So you can see that structural engineering and civil engineering is a major part of the oil and gas, but most people don't know. And the reason why most people don't know is because oil and gas works with different standards. Like, they have a very high standards compared to the construction industry. They have a very, very high standards that there is no room for compromising. You know, in the building industry, like construction industry, you can just say, okay, let just overlook this. But in the oil and gas industry, you don't overlook. You do based on ISO standards, based on standards. Everything you're doing, both your drawing must be to standard, which I'll be showing you some clips of drawings in time to come. So everything you are doing must be to standards, and because of that, there is what they call oil and gas standards. And in that note, if you must work in the oil and gas industry, be any discipline, your CV and your skill and knowledge must know these standards, because you will be tested and they will know if you know it. If you don't know, it will show in your interview, during your interview. Even if you backed up your CV with different skills, it will show. So it is very hard to move from construction industry down to oil and gas industry, because both of them have different standards, even if they use the same design codes. Yes, similar design code, the same design code, but different engineering standards in terms of construction, in terms of presenting drawing, in terms of costing. They all have different standards. Now, in that course, most of the oil and gas companies, for example, Shell, Total, Mobil, Chevron, name it, Seplat, Aradel, name it. When they are looking out for staffs, they look out for the people that actually know this skill and have worked with this skill, or that knows it. Alright? So in that course, the people that knows this skill as a civil structural engineer are very rare. Very rare, because people that knows it don't even have time to even teach the younger engineers or teach the younger ones. So in that note, these vacancies becomes very, very minimal. It's not a competitive place. There is always a chance, always a vacancy in oil and gas industry, but they will not employ you if you don't have this knowledge. Okay, so in that note, I have worked over 7 years in the oil and gas industry. I've worked over 10 years in the construction industry. So knowing, having worked in different industries in the area of civil and also the engineering structures, I said, okay, these are the problems that people are having, why they are not coming into the oil and gas. Now that Ekidel is being dedicated to train the younger engineers, and we have done this for the past 4 years, and we have seen results, massive results. We have seen how younger engineers now can boldly design structures, not just to design or to use the software, but to defend it based on code standards and based on principles, because we teach with practical based experience. So everything that we are going to be teaching, so the same way we do our practical based experience is the same way we are also going to do with this oil and gas. We are going to use a practical and real life plant design models to perform this structural training, or this oil and gas training for this. Now, you can see that on our previous, on our Ekidel videos, all the building designs that we use are real life examples. Almost 98% of buildings that you see, or the videos that you've seen us do, they are real life buildings and they are standing. Currently, they have been built. Almost all of them have been built. So we use real life examples to build your confidence, to boost your confidence, and to also, so that when you will be employed, or you like see you want to design your own, you are not thinking, oh, what I watched was a video. No, that was a real life structure you just watched. So every principle you see us apply there, if you apply it in your own case using the right terms, like the rule of thumbs and everything, it's the same way you are going to get a fully optimized design. The same way we did that, the same way we are going to apply it in the oil and gas, Ekidel oil and gas training. We are going to be using real life facility models. Now, knowing that the oil and gas industry is quite somehow, most of the files that we will be using will be highly classified. Highly classified in the sense that to fight against legal issues, because most of the companies have given us the permission, the rights to use the models, most of their models, to train the younger engineers, while most of them we are still applying that they should give us the right to use that, because we believe that when we use the right model, the right platform layouts to teach you, when you get employed, what you have been seeing on Ekidel is the same thing you will see. So it's not like a new thing to you. You understand? That's why we always use a real life example to teach. So most of the models that you will be seeing us display are real life example, and if you follow the same principle which you will learn when you'll be employed in any of the oil and gas industry, and you've given the job tasks to like to do, what you watched in Ekidel is not different from what you will see. You just follow the same principle, so it will look as if you have been working already in the oil and gas industry. You already have the experience, so it just flow together. That's the reason why we use real life examples to do this. We are doing this because we want every young engineers that is coming from Ekidel, coming from our training, or coming from our mentorship. When you go out there, you will do extensively great and understand and be proud of yourself. So in that note, because these files are very, very high classified, that's why you have been seeing delays. We have been saying we'll start last year, delays, because we have been fighting for the permission to use these files and also to share it with the younger ones, so they can have a feel of what oil and gas looks like, learn it, practice with it. That when they are employed, it's not a new thing. They have been working with it already. So based on that, most of the videos, most of the high learning videos will be on YouTube, on our Ekidel YouTube membership, and most of the training for this oil and gas will be on Ekidel mentorship, because we don't want these files to be on the public like that just for a public sake. Because if you have the file, if you have the plant facility model, then you and most of these models have been built, most of these facilities have already been like built already. For example, the biggest refinery in Africa, if you have that kind of model, like a plant model on your system, you already know about everything already. You understand? So they are very high classified that we cannot just give it out open like that. So it will be used for training, for mentorship training, and for Ekidel membership. With that, we can control how these files will be in the public, not the way you see it around, like the way you'll be seeing our Ekidel video trainings. Okay, so it will be basically on Ekidel membership. Most of the videos and the files will be live on Ekidel membership. So it is only the serious ones that want to really enter into this oil and gas, that want to have the knowledge, that will go into there. And whenever you spend money for something, you will have value for it. But when you get it for free, you can just destroy it anyhow, share it with that, because you didn't spend money for it. So it will be majorly for the people that are very, very interested in it. So it will be on Ekidel membership and mostly on Ekidel mentorship. You understand? So now this mentorship is not the general Ekidel mentorship. This is our Ekidel Oil and Gas mentorship training, which we are going to add to our seller within this month of August. And so you'll be seeing most of the things now in seller within this month of August about Ekidel mentorship, and also most videos that we will be doing, we will guide you on what to do. Okay, that is fine. So that is how it's going to be. Yeah, so from tomorrow or within this week, you will be seeing more videos, more models on Tekla Structure. Now, the softwares that we will be using for this phase of the oil and gas training is Tekla Structures, which is called, now we are training civil engineers are being divided into 3 phases or into 3 job categories in oil and gas. One, it is either you want to become a CAD designer, or you want to become a BIM modeler, or you want to become an oil and gas structural engineer. Now, when you are employed in the oil and gas industry, they will look at your CV. You will choose what you want to do, or they will assign you, okay, this is what you want to do. If your CV carries more of BIM modeling, they will assign you, okay, for your CV, what do you have? Which of the BIM software can you use? Which Tekla is one of the best in the world in terms of oil and gas because of how vast it is. So they will assign you, okay, you will become the BIM modeler, and that's only work you'll be doing, just to model BIM models, right? Like modeling steel structures, connection, different things, platforms, access platform, pipe racks, anything that has to do with modeling. You model and then generate the drawing. While the CAD designer, their own work, they know the standards of how these drawings is meant to present before printing or before sending to the clients for construction. They will now take the extracted files or drawings from the software Tekla Structures, and then make the drawing or present the drawing to standards, prepare the drawing to standard, adding everything that is to be there that consists a full drawing, like a full working drawing. Okay, now they will take all the fabrication drawings that comes from Tekla and then fine-tune them, knowing that no software can quickly give you a drawing 100%. You must pass through the software down to AutoCAD to go and do what? Clean it up and present it well. Then from AutoCAD, we now do the final printing. So the CAD designers work with AutoCAD fully. That's their major work, to make sure that the drawing that they are sending out to the clients are 100% to standards. Now, before the BIM modeler can model, they must model based on structural design. Alright? Section sizes and everything, and the bolt connection from the design. Now, before the BIM modeler can model in Tekla structure, they must get the design reports from the structural engineer. So you can see how they work hand in hand. When a project comes, the first thing first, the engineer look at the project, consider all the loads, and then design the platform or the structure to carry the load, which will give them the section sizes, the bolt connection, size of bolts, size of plates, and everything that they need based on the load they have laid it on. Now, when they are done with that, the engineers does not draw. All they do is just do what? Structural analysis and design, and generate the reports. When they generate the reports, the BIM modeler picks up the reports and then model the structure to, for the sake of providing fabrication drawings. If it's a steel structure, providing fabrication drawing, bill of quantities, bill of materials, and everything that structure will that model will need. Now, when it is done modeling and modeled to how it is meant to look like in real life, checking for clash check, like checking for the clashes between the bolts, or checking for clashes between the connections, and everything is okay, you then produce out the drawings. On bringing out the drawing, Tekla does not bring out 100% standard drawing. No software does that. So when they have done that now, knowing that they already have different jobs that they are going to do, so when they start the drawing, they will not go and fine tune it, else it will delay their time. Then the CAD designer picks up the drawing and then begin to now make that drawing to be to standards, right? So this is how work flows in the area of civil or structural engineering in oil and gas industry. Nobody does all the work. There is nothing like a full stack engineer that you do design, do modeling, and do drawing. Time will go. Nobody waits for you, because the oil and gas industry is very, very wide that as you're finishing one, you're doing the next design again. So as you finish, you just offload. The BIM modeler takes it up, model, do all the connections, bring out the drawings, and then offload to the CAD designer. The person picks it up and then do the finishing work, fine tune everything, finish everything to standard, and then print it out and then send to the send to the PMC to send to the clients. Now, each of these people that I just mentioned, the oil and gas structural engineer, the BIM modeler, and the CAD designer, they must be engineer. They must be a certified civil and structural engineer. Now, the only difference is that they have different job description. Correct? Now, in terms of payment, don't think because, oh, this one is answering engineer, he does designs, he will earn more than the Tekla. No. Oil and gas pays based on number of years of experience and based on what you can do. Right? Based on what you can do. How many softwares that you know. If you are in BIM line, BIM modeling line, apart from Tekla, if you know other softwares like Revit, that will boost your amount of money. But don't just pack those softwares inside your CV. Make sure you know it very, very well. Because when job comes for that kind of job, they'll say do it. It's on your CV. You understand? So don't just fake your CV. You have to know anything you're putting, know it. If you know only Tekla, put only Tekla structure there. So that you'll be sincere that is what you know. If you know 2, you put 2. That will boost your amount of money. But oil and gas pays extensively well anywhere in the world. They pay in dollars. They don't pay in local currency. They pay in dollars, and then when they convert to local currency, that's big money. So even the CAD designer aim well. Most times, if the CAD designer have experience more than the engineers, he will aim more money than the engineer. If the BIM modeler has experience more than the engineer or the CAD designer, he will aim more money. So it's based on your experience and how you bargain with the HR when during your interview, and how you believe. The main matters is that how you believe on yourself. If you believe what you can do, when you believe what you can do, that gives you confidence on how to bargain the price, because you know what you're coming to give to the company. So from your CV, and then you believe what you can do after your interview, for them to call you back and then you trust yourself, that will tell you no, HR, this is the amount I would like to take. You understand? So the first thing to do, know what you are aiming for. If you're aiming for BIM modeler, know Tekla very, very well. Know advanced steel if you're going for advanced steel. But first, our advice, you can see that we are beginning with Tekla because it's acceptable everywhere in the world. It's like Tekla Structure is like AutoCAD. You know, every company, Indian company, you must know AutoCAD. They have different cards. They have Z card, they have Breeze card, but what is known globally is AutoCAD. You understand? In terms of CADing, like drawing, instead of engineering, correct? And when you go for other discipline, all right, they can use Revit for their own. But for engineering, for civil engineering, structural engineering, the CAD that is known globally is AutoCAD. So that's how BIM is known when it comes to structural or civil engineering modeling, like BIM modeling. You must know Tekla. Even if they have other ones, Revit. Revit is you can't compare Revit with Tekla. Never. You can't try it. You can't compare Revit with Tekla with advanced steel. Tekla is like their father. It's very advanced. You can use it to model anything. There are some things that it can do that Revit cannot do. You understand? Correct. Just like in terms of oil and gas, as an engineer, STAAD.Pro is known globally. Even if they have other softwares like robot analysis that they use in oil and gas, they have other softwares that they use like ETABS. But in terms of, if they say they want to employ a structural engineer for oil and gas, what they want to see on your CV, the major software is STAAD.Pro, because STAAD.Pro is very, very fast. Very, very fast. You can use to model any kind of thing. Just like SAP 2K too. You can use to model any kind of shape. You know, right? Now, something like software like robot analysis, ETABS, they are limited. There's a kind of shapes that they cannot model. You understand? That they cannot design. Correct. But STAAD.Pro is widely known because of its complexity. You can use to design any kind of thing. So it's like a default for engineers in oil and gas that you must know STAAD.Pro. Same for CAD designing. You must know. So as a CAD designer, you must know AutoCAD in oil and gas. As a BIM modeler, even if they have Revit, they have advanced steel, Tekla is a must because most of the project jobs comes from Tekla. You understand? So you can see. So we are going to begin with these three softwares. STAAD.Pro for oil and gas engineers, if you choose to train on that aspect. BIM Modeller 1, Tekla Structure. That's the major software that we are going to use, which you can see on the screen here. Then for CAD Designer job description, we are using AutoCAD majorly and Microsoft Excel, which you will see the use of that Excel later. So every software you can see that. Then for BIM Modeller 2, which is going to be used, we are going to be using Aveva E3D. That falls under Modeller 2 because the reason why I put it under 2 is because as a BIM modeler for Aveva E3D, you don't need to be an engineer. You can be anything. I have seen someone that studied agricultural, like where I was working before. The guy, our BIM modeler when it comes to plant design, he didn't study anything about engineering. What he studied was agricultural science. But after school, there was no job, so he went to go and learn Aveva E3D, and he was very good. He worked in Oilsurf, he worked in Shell, he worked in Total. Currently now, he's in Canada working because he got a job. Now you can see. So Aveva E3D, you can be anything at all, anything that you study. You can anything at all. As far as you can use the software because it comprises of all the discipline coming together. You model everything together, just like the Dangote refinery is now. Just like a refinery is, you model everything together, both the cable tray, the civil aspect, structural aspect, mechanical aspect, electrical aspect, all these disciplines come together. You model it to check for clash check. If it is clashing on the software on that Aveva E3D, that means it will clash on the real life. So they only begin construction for any of these refineries or oil and gas refinery projects when they are verified that there is at least 90% model review without clash in the software, in that software Aveva E3D. When there is no clash, then they cannot begin construction. But if there's a clash on that software, they will not begin any construction until the software has verified that there is no clash. So it's a very advanced software. Now, I said anybody can use it, can learn it, and can work with it. Doesn't mean you can rush and do it. It's very difficult to learn. Very, very difficult to learn. Very hard, because you are modeling different disciplines. You model for mechanical, electrical, structural, civil. Everything you model it is very difficult. So before you must go and move into Aveva E3D, you must be an advanced BIM modeler. You must have known how to model with Revit. You must have mastered how to model with Advanced Steel, mastered Tekla, Tekla Structure, all these BIM software. You must have mastered and know very high advanced modeling skill before you can now be able to use Aveva E3D, because you don't just click and then say insert. You deal with coordinates there. Not that you go and click on column and then insert column. No, when you click on column, it will just be showing you blank. You will type the coordinates, type the height, type the width, the size, and then click enter. It will just go that place and then mount it there. So since both, even in construction, they construct these things based on coordinates. They will coordinate and then say that, put the column there. The same way you do it, you look at the coordinates and then begin to model those things. So you model on the Aveva E3D based on coordinates. Although some things you can also create like vessels, you can create those things by yourself and then mount it. But in most of the things are done by coordinates. So it's very hard to learn Aveva E3D. Although if you have advanced BIM experience, you can go in for that. So when you're enrolling for Ekidel training for oil and gas, you have to choose which of them, which you will see the prices later and the things you will learn by the end of the training, just as you have seen done in other our Ekidel training. And by the end of the training, you are going to be given a certificate of Ekidel certificate for oil and gas, which you backed up in your CV. That is fine. So see you guys in the coming weeks, which I'll be doing more videos on Teklas first, so that you can be able to know some few things to know, and also for the CAD designers too, which I will advise the younger graduate to like start with, or if you know you don't have a BIM idea yet and then you want to enter into oil and gas, start with CAD designing. Yeah, it's you will still aim very, very high. You will aim very, very high. Then if you already know how to use other software like Plant BIM Modeller, you can model some things, you can now move into Tekla Structures. Yeah, you can start with that. Yeah, you can learn that and then begin with that. Okay, that is fine. So see you guys later. And then this is a good news, because we are already beginning with this. Yeah, bye for them for now. Bye then.